In this video, I'll demonstrate how to constrain your curve fit. Curve constraints can be useful in certain applications. For example, when using a 4PL or 5PL model, it might be useful to constrain the upper and/or lower asymptotes of the curve to equal known saturation points like the NSB or B0. Also, if your resulting fit is expected to fall within certain ranges, you can define constraints to guide the curve fitting process as required. Coefficient constraints can be applied to the standard curve fit, general curve fit, or to dose-response curves. This can be configured using the fit constraint settings under the transform fit settings. Coefficients can be constrained using a fixed value or a bound. A fixed value will set the coefficient to a fixed value, while the bound setting will limit the search range to be either greater than or less than the specified constraint. You can enter any expression that results in a single numerical value, and this expression can refer to a transform output variable or TOV. TOVs are numerical values that are calculated as a result of the analysis. These could include values calculated by the standard curve fit, like the R-squared, or the curve fit parameters, like A, B, C, and D for the 4-parameter logistic curve. In the first example, I'll show how to constrain the standard curve fit transform. I have open an example protocol for an ELISA that contains NSB and B0 sample types. You can see that I've already calculated the data. And now I'd like to constrain the standard curve fit to these samples. To do this, I'll open the Properties control and navigate to the Transforms tab. Under the standard curve fit settings, I'll scroll down to Fit and open the Constraints drop-down box. Next, I'll specify which parameters should be constrained. For my assay, the A parameter is the minimum for my curve. So I'll click Add, and from the Fit Parameter drop-down box, I'll select A. Next, for the type of constraint, we can select to use the Fixed or Boundaries option. The Fixed option will allow us to specify the value to be used for the parameter, while the Boundaries option will allow us to specify a lower or upper bound, or use both bounds to ensure that the parameter falls between the specified limits. I'd like my A and D parameters to equal the NSB and B0 values, so I'll use the Fixed option in this case. So the expression for the A parameter will be NSB, and I'll add another constraint for the D parameter, again using a fixed value, and the value will be B0. Let's recalculate. On our report, the standard curve fit is now constrained so that the upper and lower asymptotes of the 4PL sigmoid exactly match the measured B0 and NSB values. Another application for constraining your curve fit can be to constrain your dose-response curves. I have another protocol that contains the dose-response curves for 4 unknown samples. You can see the parameters associated with each of the unknowns, including the bottom, top, span, hill slope, EC50, log EC50, and R-squared. I'd like to constrain the A parameter of this fit to a fixed position so that I can better compare the EC50 values. I'll again navigate to the Transforms tab, and under the Dose Response Curves transform, I'll scroll down to the Fit section and open the Constraints drop-down box. I'll click Add, select the A parameter or initial value, and instead of referencing a sample value, I'd like to reference a fixed numerical value. So I'll select Fixed and enter 294,000 to this field. Let's recalculate. Now on our report, you can see the A parameter or the top for all of my unknowns equals 294,000. The graph has also been updated to display the constrained fit. This can be particularly useful in cases where you'd like to compare the biological responses of 2 substances or environments, standardizing the curves for an easier comparison. I have one last example, and in this example, I'll demonstrate how you can constrain the curve fit based on a reference curve. So in this example, I have 2 dose-response curve transforms. The first will calculate the unconstrained dose, and the second will calculate the constrained dose. Right now, these two are configured in exactly the same manner. I have 1 standard curve and 5 unknown curves, and I'd like to constrain my dose-response curves based on the results of the standard sample. So to do this, I can use transform output variables or TOVs. I'll open my Properties control and navigate to the Transforms tab. On the second dose response curve, I'll again open the Constraints drop-down box. I'd like to constrain both the A and D parameters, again using the Fixed Constraint option. So I'll click Add, select A from the Fit Parameter drop-down box, use the Fixed option, and enter our value, which in this case will be TOV1.A.standard1. I can manually type this in, or I could select the 3 dots next to the value field to open the Advanced Expression Editor. The expression I'd like to use will reference the A parameter of the first transform, our dose-response curve, for the standard 1 sample. So I'll scroll down and select it from the available options. Next, I'll click Add and do the same thing for the D parameter. Again referencing the D coefficient from our first dose-response curve for standard 1. Let's recalculate. On our report, we can see the unconstrained fit showing different values for each sample for the bottom, top, and span, and on the chart you can see the different values reflected on the chart. On the Constrain tab, we can see that the bottom, top, and span values are all the same for each of my samples. And on the chart, we can see that each curve fit shows the same bottom and top values. So by using MyAssays Desktop's convenient fit constraint editor, we're able to constrain the various curve fits, including the standard curve fit, general curve fit, and dose response curves to meet your specifications. If you have any questions about how to add or configure your fit constraints, please email us at support@myassays.com.